We all know how to take the factorial of a positive number, but what about a factorial of a fraction? The factorial of a number is a product of that number and all the positive integers below it. We define 0 factorial as 1, and here are some definitions like 1 factorial is 1, we have 2 factorial which is 2 times 1, and then 3 factorial, 3 times 2 times 1, and we could do that for 4 factorial and 5 factorial. And now the question becomes, how do we take the factorial of 1/2? Well, in order for us to do that is use the gamma function. The gamma function gave us a continuous connection between positive factorials and those of fraction factorials. And oh gosh, the gamma function comes up in probability, statistics, I've seen it in Stirling's approximation, and many other theorems. It's just as important as the functions like parabolas and linear functions. And let me show you how we use this to find 1/2 factorial. So before we even calculate 1/2 factorial, let's talk about our players. We have the gamma function, which is defined by an integral from 0 to infinity of t to the z minus 1 e to the negative t, where z is our input and typically that's a complex value. Now we're going to need the Gaussian integral in a second. Now I encourage you to try to solve for gamma of 3 and gamma of 4 and see if you see a connection. And by the way, it's really easy to solve. All you need is some integration by parts. Now here are the properties. The gamma of n plus 1 is defined as n factorial. So if you were to find, for example, the gamma of 3, then your n is equal to 2, so you have 2 factorial, which is just going to be 2. Breaking down n factorial, we get n times n minus 1 factorial. So from this particular definition, we can say that the gamma of n plus 1 is equal to n times the gamma of n. And that's going to help me rewrite the value of gamma n plus 1, where you have n times gamma of n, which is going to be the integral that we were talking about. Now, if I make my n value equal to 1/2, you'll notice that that's going to equal to 1/2 factorial. So if I'm trying to find 1/2 factorial, I just need to find 1/2 times the integral of this particular value. I think it helps if at this point I make a substitution. So now through this substitution, I go ahead and rewrite my integral. The 2 and the 1/2 are going to cancel out. This particular u and that u to the negative 1 is going to also cancel out, which I'm hoping you could recognize is simply the Gaussian integral. So at the end, we get that 1/2 factorial is equal to the square root of pi over 2.